So at this point, this is the architecture we're basically dealing with. It's a single region, high availability design, just so we can understand how the Azure load balancer works. And so far, we've built out the web servers in 2 different availability zones. And in this video, we're going to build the load balancer. And it's going to be pretty simple. We're going to come up to the load balancer, hit the outside interface or the public IP address that's connected to that load balancer. And then we'll see that it can distribute connections across both of the availability zones and that we can sustain an outage of one of those web servers going down or the availability zone going offline. And so once you know how this works, you'll basically get the gist of how the application gateway can load balance virtual machines across 2 different availability zones. So let's jump into the portal and we'll set this up. All right, so back in the Azure portal, let's go create a resource. We'll go to networking, and here's the Azure load balancer that we're talking about throughout these last few clips. This is the application gateway. So we're going to choose the load balancer because this will create much faster than an application gateway. And so we'll give this a name. Doesn't really matter what we call it. We'll just call it MyLB. The type here is going to be public. And remember, it can be internal as well. So you might have multiple load balancers within a highly available design. And I'll show you an example of that here coming up. Now, in terms of the SKU, notice that we have basic and standard. If you highlight the little information icon here, it says choose a standard load balancer for up to 1,000 instances and for zonal and zone redundant scenarios. So that's what we want to do. We want to pick standard here. And then we're going to need a public IP address since this is a public load balancer. So we'll just give it a name. We'll scroll down, and for the availability zone configuration, we're going to say this is going to be a zone redundant load balancer. So this will allow us to send connections to both the virtual machines that are eventually going to be in the backend pool for this load balancer. We'll put this in the existing web servers resource group. And that looks good. Let's go ahead and create the load balancer. And after a minute, that deployment succeeded. So let's head over to that resource. And we can see that we have a load balancer. It's not configured. It does have a public IP address on it and has nothing else configured. So what we got to do here is basically fill out this information here. We got to build a backend pool. That's the backend web servers. We need to build a health probe so the load balancer can make sure that those servers are healthy before we send any traffic over there. And then finally, we get to set up a load balancing rule telling the load balancer what we actually want it to do, like what traffic should it be distributing across those backend servers. So on the left-hand side, let's go to backend pools. We'll click on add. We'll call this web servers. We'll pick the virtual network we created earlier, and we're going to add the virtual machines, Web 1 and Web 2. And notice that I'm associating this to the network interface, the individual single network interface that are on those servers. So let's go ahead and add those servers to the backend pool. And now that that's built, backend pool is set up. We've got 2 virtual machines in that backend pool. Let's go over to health probes here under settings. This will allow us to make sure that the web service is running before we send users to these servers. So we'll call this HTTP. And we're just going to do a TCP ping on port 80. So we'll just pick the rest of the defaults here, click OK. And now that that probe has been built, the last thing is go to load balancing rules here under settings, and we just need to create a load balancing rule. So again, to keep this simple, we'll just call it HTTP. We can see the front end IP address that was already created as we built the load balancer. And again, with this Azure load balancer, we've got TCP and UDP protocol support here, but we're going to load balance TCP port 80. That's just the basic web application. We're going to send traffic to the backend pool, our 2 web servers running in 2 different availability zones, and it's going to be connected to the probe that we just built. And we don't need any session persistence. We're just doing some testing here. So let's go ahead and click OK. And that load balancer rule has now been saved. So everything looks good. Let's close out of this. Let's go back to resource groups, go to the web servers resource group. Here's our public IP address resource. And here's the public IP. So what we want to do is just grab this public IP. We could go off into DNS and create an entry for this, but we're just going to test it manually here. So we're going to open a new tab in Chrome. I'm going to paste in the IP address. We'll head over there. We see Web 2. So if we hit refresh here, it's not actually bouncing between Web 1 and Web 2 because the way the Azure load balancer works is that's basically going to keep me with Web 2, the first server I connected to. What we could do to test this, go back into the portal, go to web servers. If we scroll down, we go to Web 2. Under support and troubleshooting, go back to the serial console. And then we're still logged in here. So what we'll do is clear the screen and we'll do a service Apache 2 stop. So that'll kill the web server, of course, on web 2. And that means if we head back over to this tab and hit refresh, the load balancer should figure that out. And now we're seeing web 1 on the screen here. So when that happened, the load balancer did a health check on web server 2. It noticed that the web service was dead. And now it's routing the connections to the other server in the other availability zone. So basically, we simulated an outage with an individual server, but this would be the same experience if the entire availability zone inside that region went down. So as you can see, this is really powerful when you're building these highly available designs. Let's go back in the portal real quick. I want to show you one other thing. If we go to create a resource, go to networking, we've got the application gateway. And basically when you build the application gateway, it's going to be very similar for the most part. There's going to be additional bells and whistles that you have with this particular piece of infrastructure. And again, the application gateway is built for HTTP only type of application. So it's only for web applications. And then when you get into the settings, you'll be able to do things like pick web application filtering. You can do SSL offloading, and you'll have more affinity options in terms of keeping users with the same server based on cookies. And you'll have a lot more capabilities, and it's more of a web application load balancer experience. And based on the SKU size here, there's going to be different costs associated with the application gateway. So it's definitely a different animal in terms of the cost. But when you're building a highly available design, this might be an interesting option, especially if you have large-scale web applications. So now that we know how to load balance in a single region across a couple of different availability zones, let's go to the next video and we'll talk about multi-region solutions.